Alright, so we are coming to section B. So this part here is on the electric vehicles. So you can read all of this. This is a diagram showing a hydrogen fuel cell. How does it work? Okay, then we are given a table here with obviously 3 blanks that I've just filled up. This is a diagram for the lithium-ion battery. Okay, so they want us to complete table 8.2, right, on hydrogen and octane. So we're going to use the values that are given actually in the table to help us calculate. So I think we're going to calculate the density of octane. What is the density, which is the mass divided by the volume, right? So we are given what? Given the volume of 1 mole of this fuel. Okay, so that is the volume. So we have the denominator. What is our mass of octane? So we got to look at the MR, right? So MR is 114 divided by the volume given here. We get 704. Mass over volume gives us density. So this is our answer for the first blank. Okay, the second blank is enthalpy change when 1 mole of fuel. Enthalpy change when 1 mole of fuel is completely burnt. Okay, so here they are saying 1 kg, right, completely burned. This is the enthalpy change. How about when 1 mole is completely burned? Okay, so we got to convert that. Okay, so for 1 mole here, right, 1 mole is 24 dm cube. From the density, we know that 1 dm cube will be 0.083 grams. So 1 mole, right, which is 24 dm cube, is this 0.083 grams times 24 dm cube, which will give us about 1.992. This is the mass in 1 mole. Okay, 1 mole of hydrogen. We are told that 1000 grams, right, will give us 143,000 kilojoules of energy. So how about just 1.992 grams? Okay, so we're going to take 143,000, multiply that by 1.992 over 1000. Okay, so we get our answer, negative 285 kilojoules per mole. All right, so we just fill this answer into the table. Okay, last of all, we are told that to find the enthalpy change of 1 kg of fuel. So we already have the enthalpy change for 1 mole of fuel. So we just need to find out 1 mole of fuel, right? What is the mass in 1 mole of fuel? Okay, so 1 mole of fuel. Beg your pardon. So we already given 1 mole of fuel, right? How much energy it gives out, which is negative 5075 kilojoules. So we're going to find out, right, for 1000 grams, like instead of 1 mole, we want to find out 1000 gram, what is the number of moles here. So 1000 gram divided by the MR. So this is actually mass divided by the MR of octane. So we get a grand total of 8.77 moles. So since 1 mole gives us about 5000 kilojoules of energy, 8.77 multiplied by this amount for 1 mole will give us the energy enthalpy change for 8.77 moles, which is also aka for 1 kg. All right, so we will put this number, negative 44,500, into our table here. Okay, so that's how we fill up the whole table. Okay, part B, using information from table 8.2, evaluate the use of hydrogen and octane as fuel. Okay, consider the ease of storage or the energy content of the fuel. Okay, so in terms of ease of storage, right, octane definitely is easier to store because it is a liquid. Okay, in fact, this is what we are using in our vehicles now, right? Petroleum, which is liquid. Okay, but hydrogen is a bit more difficult to store because it is a gas and it is explosive. All right, so if you want to like store it as a liquid, you have to store it at very, very high pressure, which is pretty dangerous if you want to do that in the vehicle. So that's number one, ease of storage. Energy content wise, right, you can see that hydrogen is a lot more energy efficient because it releases more energy per kg. Okay, that's for the second point, energy content. Write the half equation for cathode and anode. Okay, guys, this cathode and anode equation, you got to remember how to write them and how to balance them. Okay, just memorize them. If you cannot derive them on the spot, you got to learn and memorize them. Okay, these are very, very important. Okay, so energy output can be shown in the energy profile diagram. So here have this is for with or without catalyst, right? With or without. This one is without. So exothermic go up, come down, and then you have your products. This here is your EA. And then from here down is your delta H combustion. Okay, so same thing we're going to draw for the catalyzed reaction, but the EA is much lower. Products, same delta H combustion. This is your EA prime. Okay, for the catalyzed reaction. Okay, part E, lithium ion battery is different from conventional simple cell. Compare and contrast the two types of cell. Okay, so conventional simple cell uses two metals of different reactivity, but lithium ion, right, uses only lithium. Okay, so this is like one difference. In the conventional simple cell, right, the more reactive metal is the anode, whereas lithium ion cell, graphite anode is used. Okay, so you can check out the diagram. Lithium ion cell, right? Where did they say? Yeah, graphite anode. Okay, so that is the difference that is shown here. Okay, last part, oxidation occurs at the anode when lithium ion battery is charged. Comment on the validity. During charging, right, what is happening? Electrons and lithium ion move out of the cathode towards the anode. So this is actually a reduction process. Because during charging, right, what we are doing is we are using electrical energy to reverse the flow of the spontaneous reaction. Okay, so we are charging, we are storing the electrical energy so that it can produce a spontaneous chemical reaction later on. Okay, so in essence, when you are discharging, right, when you're using the electric vehicle, then the anode will give out the electrons again. That is the spontaneous process. Okay, so this charging is the non-spontaneous process. You use electricity to drive a non-spontaneous reaction. All right, so it's the opposite of what is happening in a simple cell. Hi parents and students, I'm Mr. Kwa, founder and principal tutor from Mr. Khemistry. I do these videos to help more students understand difficult chem concepts, and hopefully more needy students who are not able to afford tuition, they can benefit from these videos. Please help me click that like button and share it with your friends so that more students can benefit. Thank you and see you in the next video. Bye.